Okay, so we're going to explain the chain rule, and I'm going to explain to you guys the easiest way I know to use the chain rule that works for easy functions as well as very, very complicated functions. Now the chain rule, you use it when you have a composition of functions. So let's say I have a function made up of, let's say, two different functions. So this would be f of g of x. And let's say that I want to get the derivative of this composition of functions. So what the chain rule says is that you're going to get the derivative of what we're going to call the outside function with respect to the inside multiplied by the derivative of the inside. Okay, so now what I'm going to do is I'm going to write down exactly what this formula is telling us to do in words, and we're going to use that and apply it in some example problems. What this says is that find the derivative of the outside function. Whoops. Leave the inside alone. Leave the inside alone. Then multiply by the derivative of the inside. Okay, and so what we have is this situation where we have an outside function. So for example, in this very first example we have this is a composition of functions where the outside function is the square root function, and the inside function in this case would be e to the x plus 1. So this is what we mean by outside and inside function. This is the outside, and then this is the inside. Okay, and so the way it works is that it's kind of like you have these Russian doll situation where, okay, so I'm not very good at drawing, but let's say you have a Russian doll made up of, maybe I'll just draw little eggs instead. And so we have these little, let's say this is sort of like a little egg. Now this is going to sound kind of silly, but this is the way the chain rule works. Is that you have, so here this is, the blue is the most outside function. Inside this is the green function, and then inside that is the black function, and inside that is the red function. So the way it works is that you get the derivative of this function first, the blue one, and when you get the derivative of that, you leave the inside alone, but then you've sort of in a way cracked the shell. And once you've done that, then you move in for the next one, and then you get the derivative of the next inside function. So once you've cracked that shell, you're going to go back inside and to the next one, and you're going to get the derivative of the next inside function. And really, I mean, you can keep doing this forever, depending on, well, you don't really have functions. In our case, at least, they go on forever, but you can do this for quite a while, and some pretty big functions until you get to the most inside function. So this is a case where we have 1, 2, 3, 4 functions. So now let's try to apply this idea to this simpler function that we have up here. Okay, so remember that the very first thing we do whenever we have roots and we want to get the derivative is we're going to write it down as a fractional exponent. So instead of e to the x plus 1, square root of e to the x plus 1, we're going to write it as e to the x plus 1 all raised to the 1/2. Okay, so notice my outside function here is this function that's being raised to the 1/2. And remember that when I have a function being raised to a power, I can use the power rule. Now let's try to use what we just talked about here in words. It says find the derivative of the outside function, which is this guy that's being raised to the 1/2. So that means that I'm going to use the power rule. So that means bring the 1/2 over to the front. And then remember, you leave the inside alone. And then you subtract 1 from the exponent. So 1/2 minus 1 is minus 1/2. Okay, so this is what we just did. We found the derivative of the outside function. We left the inside alone, which is right here what we did. And then now we're going to multiply by the derivative of the inside. So now we move in. And now this is kind of like we've cracked the first layer of the shell. We're moving into the next one, the inside. So now we want to get the derivative of the inside. Well, the derivative of e to the x plus 1, we just find the derivative of each one. So the derivative of e to the x is just itself, e to the x, and then plus the derivative of 1, which is 0. And we can simplify this a little bit. This isn't part of the chain rule, but we can turn the negative exponent positive, so we can have 1 over 2 e to the x plus 1 to the positive 1/2 times e to the x. And that's just a different way of writing it. Okay, so I hope it's clear what we did. We found, let's go back and review again. So this is our function. We found the derivative of the outside, which is this guy that's being raised to the 1/2. So that means we use the power rule, bring it out in front. We get this 1/2. Leave the inside alone, and then we are going to subtract 1 from the exponent to get negative 1/2. Once we've done that, then we get the derivative of the inside, and that's where we get e to the x plus 0. And this is just a simplifying step. And then we're done. So I did that one pretty slowly, and we'll move through the other ones quicker, but this is the main idea. So let's try the next one.